Hello and welcome everyone. I'm Nissan Paudel and I'm very excited to be with you today to kick off our video series on thermodynamics for especially 11th or 12th graders. So let's go.
Okay, thermodynamics. And what is thermodynamics? Thermo, as you can guess from the title, it's about the flow of thermal energies, right? So, informally, we can define thermodynamics as the study or as the branch of science which studies which studies heat, energy, and work. So, I'm going to discuss about all of this, and chapter wise, I will first start with heat and temperature, which is a pretty fundamental thing in it. So we'll go one by one. What is heat? First of all, what is heat? Heat is that energy that can transfer from one body to another. So we define it formally here. It is the energy that can flow from one object to another. And what measures this flow of energy? We have to quantify. We have to find something about an object, so that we can determine from which body the energy flows to which body, and that comparison is done using temperature. Temperature actually determines the direction of flow of heat energy. So temp- and we quantified this temperature. We quantified this property of objects as temperature in numbers. So temperature is the quantitative measure of transfer of heat from one object to another, and in general it's defined as the degree of hotness or coolness of a body. Then what does this temperature does is actually measures the internal kinetic energy of the object. Since we know heat is an energy and it's an intrinsic property of an object, it cannot be a potential energy. It cannot be totally internal energy, because potential energy can transfer from one object to another. So it's just the kinetic energy of the object. So let's move on now to thermometry. What is thermometry? It is the science of temperature and its measurement. So in thermometry, we have a lot of things to discuss about. First being thermometers, which measures the temperature of the objects and their construction, their markings, their scaling. A lot of things comes under this, and we will study it in detail right now. So in thermometers, especially the measuring tools are thermometers, and in thermometers we have generally seen mercury thermometer, alcohol thermometer, and digital thermometer. So we'll discuss about it. What is and this figure of thermometer that you can see in screen here, you can see the bulb. It contains mercury, and here's a capillary in which the mercury expands to, so that we can know the temperature of the object. We will learn about it. What does this how are these thermometers made? These thermometers utilize the natural properties of an object. Some materials changes, the property of some materials changes with temperature. Thermometer, we use that property to determine, to mark different different temperatures in thermometer. For example, volume of objects expands. In generally in liquids, volume expands when temperature rises. Similarly in mercury and alcohol, in mercury and alcohol thermometer, property of these liquids to expand due to the rise of temperature is used to make a thermometer. We will discuss mercury thermometer in more detail now. This is the mercury thermometer. It's quite smaller. Alcohol one is quite bigger because alcohol expands more. So how is it made? In As I said earlier, in this glass bulb, mercury is present, which expands to this capillary when temperature is raised. Then we can measure the temperature. As I said it earlier, and in capillary we mark different positions. Mainly we will discuss about its construction later on, but I'll just touch upon it. Melting point of ice and boiling point of water are two checkpoints to actually make a thermometer. So that's how we make it. And alcohol thermometer are also similar to mercury thermometer, a little bit bigger and defect with alcohol thermometer is that the expansion is not uniform over the temperature range of measurement. So mercury thermometer is preferred over alcohol thermometer, but thermometers can be anything. We also have digital thermometers nowadays that utilizes the resistance of material as the fundamental property that changes with temperature to measure temperature. So let's move on now to types of thermometer. We have discussed the liquid thermometers. Mercury and alcohol thermometers are liquid thermometers, and similarly different other types of thermometers are also possible. Some examples are gas thermometers. Okay, in gas thermometer we know in a fixed volume, if gas is kept and its temperature is rose, then the pressure inside that volume increases rapidly. So if we can measure that temperature, we can identify each temperature pressure point as a temperature. So in this way gas thermometers are built. Similarly, there are resistance thermometers. Digital thermometers are used using resistor thermometers, resistance thermometer. For example, in if we use thermistors, the change in temperature also changes the resistance of that material, and um, uh, we can signify different amplitude of currents to temperature. This way resistance thermometers are built, and similarly thermoelectric thermometers. In thermocouples, EMF is generated if there is a temperature difference between at the junction of two materials. So thermoelectric thermometers can be used using this property. If the temperature difference is high, higher EMF is generated, so we can signify higher temperatures with higher EMF produced. I, so on. There are other types of thermometers as well. So, now we will discuss about temperature scale. There are a lot of temperature scales, but mainly we will talk about three temperature scales, and two are very common up to now: centigrade scale and Fahrenheit scale. And a more scientific scale is Kelvin scale or absolute scale. Also, we will talk about all these things. What is centigrade scale at first? In this scale, 0 degree represents melting point of water and 100 degree represents boiling point of water. And in Fahrenheit scale, 32 degree represents melting point of ice, sorry, melting point of water, I can write that also, and it must be 212 degree Fahrenheit represents boiling point of water. And similarly, in Kelvin scale, 273 Kelvin represents melting point and 373 degree represents boiling point. I think it's more accurate is 273.15 Kelvin representing melting point, and similarly 373.15 representing boiling point. Okay. In the interesting property of absolute temperature is that at 0 Kelvin, it it says internal kinetic energy is 0. So it is actual measurement of kinetic energies. Unlike others where 0 is not absolute 0, but in absolute temperature scale, 0 Kelvin means absolute 0, that is 0 kinetic energy. So this is very interesting, and in physics we will often use absolute temperature scales other than rather centigrade scale or Fahrenheit scale. So it is very important temperature scale to learn about. I think I made some corrections in the later present slides, so let's go to them. Okay, now we will discuss about relation between different scales. Since we have different ways of representing temperature, that is centigrade, Fahrenheit, Kelvin, we'll need to find a way to convert from one scale to another. So in figurative form, you can look at this picture here. Boiling point of water is 212 degree Fahrenheit in Fahrenheit scale, 100 degree Celsius in Celsius scale, and 373.15 Kelvin scale. And similarly, for melting point of ice, you can see three different temperatures in different scales. So how can we convert it? It's just we will just take the ratio because all these temperature scales are linear, so we can compare their ratios. So this is the way. C minus 0. 0 is always the 0 degree Celsius is the melting point of ice, and in numerator we are taking the ratios of the temperature at the current moment minus melting point of ice divided by boiling point minus melting point. So we can equate these ratios because all in these temperature scales the change in temperature is linear, right? So it's pretty common and it's very easy to understand here, and we simplify it to give C by 5 equals to F minus 32 by 9 equals to K minus 273.15 divided by 5. So this is how we convert from different scales. It's very easy. You can get the intuition, I think, from this figure also. So let's go. Now I think we will learn to make, we will first talk about thermal equilibrium and Zeroth law. What is thermal equilibrium? If two bodies have same temperature, they are said to be in thermal equilibrium. Or if heat does not flow from one body to another, they are said to be in thermal equilibrium. And Zeroth law is a very fundamental property related to thermal equilibrium. So first let's learn about thermal equilibrium, and I will show you some slides as well. Thermal equilibrium. If two systems have same temperature, they are said to be in thermal equilibrium. As I said earlier, and now Zeroth law. If two systems are each in thermal equilibrium with a third system, then they are also in thermal equilibrium with each other. For example, if A and B have same temperature and C and B have same temperature, then A and C have same temperature. It's a very easy and a very basic law which we define just to build our basics to the language of physics, right? So let's see an animation on this Zeroth law. Here, C is an object connected to A and B. When A and C and B comes in thermal equilibrium, all three are in thermal equilibrium. I think this animation is very useful and helpful because you can also think of it as the transfer of kinetic energy among A, B and C. Then now we'll talk about construction of Mercury thermometer. What is you can see this figure here. Now how to make a thermometer? As I said earlier, we have to compare to a physical property. We have to compare temperatures to physical properties. Here, we first mark the volume of mercury when it's kept at ice, and then again mark the volume of the mercury when it's kept at steam. So how do you do this? In this figure, we put the mercury in that bulb a little bit above that can rise to capillary at normal temperatures. When we put that in ice, the mercury contracts to a lowest point, which we mark here to represent it as 0 degree Celsius or in any other temperature scales. For now, we will talk in Celsius scale. Here, this point, if my pointer is visible, this point marks 0 degree Celsius. And again, when we put that same thermometer in steam, the mercury inside the capillary rises, volume expands, and this is another point where it stops expanding, and this is the volume at 100 degrees Celsius. So when we are measuring temperature, when the mercury rises to this point, it means that it is at 100 degrees Celsius. And since in mercury the expansion is uniform over the range of temperature, we can divide this whole sections with equal markings to denote different temperatures. So this is how we make a thermometer. I hope you understood it, and I have just made it a pointwise so you can take a look at it. First, mercury is poured in the bulb and capillary, then it is kept in melting ice, and the level of mercury is marked at 0 degree Celsius. Again, it is kept above boiling point and level of mercury is marked as 100 degrees Celsius. So this is how you make a thermometer. So thank you for joining, and I'll make the videos on, I'll make this whole series on thermodynamics. So I hope you will stick around and share and like this video. So thank you for joining. Bye bye.